Hi guys, I'm Reyes and I'm going to talk about Euler's method and formula. So, given that dy over dx is a function of x and y, and x0, y0 is the original position. So, when it reaches x1, y1, okay, you can then form a gradient by connecting both points. Okay, as you can see on the screen, rise over run. After that, you make y1 the subject by cross multiplication, then bring y0 over. Okay, after that, m, which is also the gradient, similar to dy over dx, which is the gradient of function y. Therefore, you can sub in the dy over dx as f x0 y0. Okay, which also means that it's the gradient at x0 and y0. Next is the x1 and x0, which is also the step size, which is also known as h. Okay, so what is step size? It is basically the increment of x value. Okay, therefore it's always constant. Okay, so if let's say you want to find y2, okay, you basically take f x1 and y1, which is the gradient at the position 1, h, which is constant, and y1, which is the position at first position. Okay, then as you can see, there's a pattern, and therefore you can develop the Euler's formula over here. And now we can transition to the next section. Now let's try to solve this question using Euler's method. First, create an Excel sheet with 3 columns, x, y, and dy over dx. We assume that the step size is 0.1. Values given is that when x equals to 0, y equals to 1. For dy over dx, we were given is x over y squared, so you can key in this in the formula. After we handle the first column, we can proceed to the second column. Since the step size is 0.1, the yellow box is equals to x plus step size. For y, which is in orange color, we can use the Euler's formula that we solved earlier. Here is the formula and how it's keyed into Excel according to its color. Okay, if done properly, the approximate value for y1 for step size 0.1 is 1.34. We have to solve this equation using the general solution. So as you can see, it's a separable ODE. Okay, then basically you have to bring the x one side, y one side, then integrate both sides. Okay, after that, you have to find the c value of this equation. So y0 equals to 1. So basically it means x equals to 0, y equals to 1. Okay, so after that, you can find the c value. Then this c value can form an equation over here. So after you form the equation, you want to find y1. So it means x equals to 1. And then you can get the value over here. To solve for the approximation value, the formula is as follows. Approximation error equals to general solution method minus Euler's method over the solution method. If we key in this value into Excel, we can then identify the approximation error for each value of y. This table shows the value of y that is solved using Euler's method, which is in green. It also shows the y value using general solution method, which is shown in yellow. This error increased from 0 to 0.6, then it decreased after 0.6. To make the approximation value more accurate, we should include more data, so we could use a smaller step size. This table shows a table size of 0.01, and there's an error. But this data is much more reliable compared to the step size of 0.1. Thank you very much and hope to see you again.